So we've gotten past midterm 2, we've talked about file input and output, and actually by now, pretty much any task we want to perform, we have the tools to perform. The problem is some tasks might be unwieldy, and it turns out that all we have left to discuss for the rest of the course is pretty much data management. It's being able to, now that we have the tools to read huge amounts of data out of a file and to, I guess, store them in memory with things like arrays, and we know all the logic we need to process things, now the question becomes, how do we make sure that our data is stored and organized in a way that makes it manageable so that we can actually do that work on it and it doesn't become anarchy? And in this video, I'm going to begin this progression. It turns out the thing I'm going to get to in this video isn't really that useful. We just need it as a stepping stone to the next 2 videos. But basically, we have the power, now that we have files, to work with huge amounts of data. It's just that maybe it's so cumbersome to do so that we can't get anything done. So for the time being, let's start with this problem here. I might have a C program that I'm using to track a database of customers and the orders that they place. Maybe this is joined up to some sort of inventory system. So maybe a customer places an order and I want to keep track of things like how much did the order cost? And I suppose each order has an order number. And we might think about this happening in the setting of some larger program that's working with hundreds or thousands or millions of orders. Or I might want to ask questions like, here is all of the orders I received this year. Tell me how much money I made. Tell me what the average price of an order was. Tell me which customer placed the most orders or which customer placed orders worth the largest amount. Tell me the average price of every order with an order number between 1,000 and 2,000. Things like that. Working with orders in aggregate, not necessarily just with order numbers, not with prices. I want to be able to hand over to a function, here is an order, tell me something about it. Or here is a list of orders, all the orders I got from February, tell me something about those. So I want some way of organizing my data that maybe puts emphasis on the idea of an order as a complete thing. And each order consists of these pieces of information. But I want to talk about an order just as an order, not specifically as the combination of order number, price, and the customer's name. So we already have a couple of ways of combining together pieces of data and referring to them by one name. For example, if I wanted to talk about vectors in 3D space, here's a vector in 3D space, I could store this entire vector as apparently one variable, not 3 independent variables. We know how to do that already. We did that on assignment 4. I could create an array of type float or an array of type double. Now the variable named v refers to the entire vector, the entire 3-element vector. I found a way of grouping together data into a single variable. But the problem is arrays don't really work for this question. For this question, I want to group together 3 pieces of data that are distinct. They're not the same type. I suppose we could cheat a bit if we didn't have to worry about the customer's name. If all we had to worry about was the order number and its price, we might be able to make an array of floats and store the order number as a float. That would be a bit sloppy, but maybe we would get away with it. But I can't think of any particular array that would allow a name, so a string, the name of the customer is a string, a name to cohabit with the price, stored as a float, and an order number stored as an int. I want to store all of those things under one roof, but an array won't let me do it. So we have to talk about some other technique. It turns out we really need the ability to structure our data. And so we're going to talk about structured data this week, and that's going to pivot towards next week where we're going to talk about something called a data structure, which is not the same thing, but it's sort of related. Here is what I want conceptually. Inside of my scope of main, there it is, I would like, conceptually, I'm not going to draw this out all the way, I would like to make a single variable as a proof of concept, a variable called ord, and it's going to refer to one order. Okay, but wait, what's an order, Bill? An order is the combination of an order number, a price, and the name of the customer that placed the order. So my variable, conceptually, should be one big bucket full of data, one container with 3 parts. The order number, which maybe we'll call ID, the price, which I think we can just call price, and a string, which will be of some particular length, but no more than 100 characters, which means I'll need an array of length at most 101 to store it. So there's my string there. And the string stores the customer's name. There it is. I would like all three of these components to be part of this big container. They're all just one variable in my program. They're all combined together, and they have distinct types. And that's one of the reasons we can't just use an array for this. The ID is an int, the price is a float, and the name, of course, being a string, is an array of characters. So I need this ability. This video is just going to talk about the concept. How we actually shoehorn this into our usual thoughts about types is something we'll talk about in the next couple of videos. So I would like a variable called ord. Now, the question we really should be asking here is, okay, great, Bill, we can combine all these things into what you're calling a container, but if this is a variable on my diagram, what is its type? And it turns out that the answer to that question is what's going to separate this video from the next one. The fact that the type I come up with is going to be a bit unwieldy. So I want to make a variable called ord, and I want to give it some type, such that apparently ord is a container with three things inside it. And then I want to talk about how to use these containers. Okay, so the first thing is we have the ability to do this. We have the ability to define a variable whose type is actually the combination of several other pieces. And we call such a variable a structure. And we're going to talk this week about defining structure types. So I'm going to create one variable called ord, which contains three components. And we typically call these components the members of the structure. So I do it like this. And of course, I'm going to use multiple lines for this because it'll make it a little bit less messy looking, but I'm only doing that as a stylistic convention. I could make this one horrifying single line declaration. So what's going to be inside my structure? I would like my structure to have an int, which will be its ID. So we'll call that, I'll actually call it order ID to be clear. I also want it to have the total price, which will be a float. And I want it to contain a string that can have length up to 100 characters, which means the array needs to have 101 positions. So we'll call that, actually we'll call it customer name, and it will have length 101. Okay, so what I have done here is declare one variable, and that variable's name is ord, and it is a structure whose members are the order ID, the price, and the customer name. So ord is one variable. And I guess now the question should be, okay, so we have this variable that's a container full of multiple different pieces of data. And of course, it should be clear, it's easy to allow them to have multiple types. But how do I use it? How do I go in and look at one of the individual members of this structure? And I'm actually going to use an operator that we've seen. It was way back in September. It was on our precedence list, and it is an operator, but a lot of people don't even think of it like an operator. They just think of it sort of like a natural extension of notation. I would like to set the order ID of this order, ord, to be, I don't know, 6. I sort of do know it was going to be 6. So I would like to get this configuration here. The ID is 6, the price is $18.70, and I'll put in a name, but I won't write it into this string here. So I write it like this, ord dot order ID. That is the dot operator. And the price will be 18.70. And I will, to set the string, we know already that once a string has been created, once the array has been created, I can't just use the equal sign. I have to use something like string copy. And maybe I'll go up here and I will include string.h, which I forgot to do in my preparation. All right, so I'm going to copy into the member called ord.customerName the string, and then we'll give the customer a name. Seems like a fair enough name. Okay. And so what I have done here is I have first created a single variable that is a container with 3 members, and they each have a name. And then down here, once I've created the variable, I can use that variable, and I can go into it, and I can refer to each of its members. And when I use the dot operator, and this will be very significant later, the dot operator can only be used if the thing on the left of the dot is of some structure type. And also to be clear, the type of the variable ord is a structure whose members are an int called order ID, a float called price, and a character array called customer name. The type of ord is not struct. Ord is an example of a structure, but the type of ord is a very specific structure, this one. We may actually be working in this course with many different variables of structure types. It is incorrect, it is absolutely incorrect to say the type of ord is struct. No, it is not. The type of ord is a combination of an int called order ID, a float called price, and a character array called customer name. Okay, so I will now go into it, and I will use the dot operator to set order ID to be 6, price to be 18.70, and then I will refer to the member customer name, and I'll pass that into this function called string copy that we've seen already. Just like when working with arrays, if I use the dot operator to refer to a specific member of my structure, once I've done that, the full expression ord.price, we know that price is a float. Ord.price, in this context, it can be treated just like any other variable of type float. I can set it to something with the equal sign, I could make a pointer to it using the ampersand, I can pass it into a function. And same thing down here. I have this character array, ord.customerName. Once I've referred to it in full using the dot operator, it behaves just like any other string, so I can pass it into string copy if I want to. Okay, the next task is, okay, so now that I've installed these values, how do I know that that worked? I should try printing them out. So I'll try printing them out with a printf statement. I will print order, and then I'll print the order number. I guess I'll print the customer number in brackets, and then I'll say the total price is, and then $, and then I will print the total price. I will print it using %f, but I'll use %.2f, which means that I always get 2 decimal places because it's currency. It makes sense to do it that way. And then I'm going to have to negotiate this text around my existing diagram. Okay, so what's the first thing I want to print out? %d for order number. I do ord.orderID. The second thing I want to print out is the customer name. That's a string, so ord.customerName. And then the third thing I want to print out is the total price. All right. So let's add a \n and then try compiling this. And we can see there it is. I print out order number 6, the customer name here, and then the total price is $18.70. So what I've been able to do is create a variable that now contains several other components. And as I said, the typical term we would use for each of these individual components is a member of the structure. This is the member called order ID. This is the member called price. And we have this special operator called dot that allows us to go in and retrieve a member of our structure. And the dot can only be used if the thing on the left of the dot is of some structure type. We'll see in a couple of videos we begin working with things like pointers to structure types. We can only use the dot if the thing on the left actually is of a structure type of some kind. There is a problem though, which is if I want to begin working with these order objects, I might want to pass them around my program. I want to make arrays of them, send them into functions, and of course to do that, and frankly just for completeness, it's really important to me to know what is the type of this variable. Okay, well the type is this whole mess, and that's not very portable. I don't want to have to keep writing this whole mess out every time I want to refer to an order object. It doesn't really make my life easier. What I want to do is to create some type called order. And every time I want to make a new order, I just declare it like I would declare an int or a float. And so the video that you're watching right now, this video isn't enough. We don't quite have a solution to my original problem. We have this interesting feature of making these structure variables, but we need a little bit more to turn them into their own type. Ideally, we want to be able to refer to an order no differently than an int or a float. I want an order to become a first-class citizen of the world of types, and that's the thing we'll talk about in the next couple of videos.